Hello people, welcome back. This question is from GATE 2020 exam and is for 1 mark. It is of the type true false. Let us read statement number 1. Statement number 1 says, a router does not modify IP packets during forwarding. This is false. See, a router will modify IP packets before forwarding. Suppose TTL of some incoming packet is say 3. Router will reduce this value by 1 and update the TTL to 2. Okay. Now because you have updated value of some field in the IP header, then header checksum has to be recalculated and updated. Okay. So router will also modify header checksum. And there is a possibility that record route might be selected by the source. So router will also add its own IP address in the header of IP packet. Okay. Moreover, router can simply decide to fragment the packets, right? So if this is the original datagram, router may decide to create smaller parts of this original datagram and create smaller fragments. Okay. So statement number 1 is false. Statement number 2 says, it is not necessary for a router to implement any routing protocol. True. Routing protocols, their main purpose is creating the routing table. Routing table is then used for deciding on which interface should a incoming packet be forwarded. If you don't have any routing protocol, this means you will not have a routing table. So simply forward the incoming packet to all of the interfaces. That means if you don't want to implement a routing protocol, you can use the method of flooding. It will increase traffic, but still these routers will work. Okay. And you can also use the router in your home network. Maybe your home network is not at all connected to the internet. So in that case also, the router is not going to need any routing protocol. Okay. Statement number 3 says, a router should reassemble IP fragments if MTU of outgoing link is larger than size of incoming IP packet. This is false. See, a router will never ever decide to reassemble all of the fragments. It is duty of destination to reassemble the fragments. Let us look at this example and let us try to find the reason for this. Suppose source creates a IP datagram of 1000 bytes of data and a 20 byte header. The first router on this path decides to fragment this datagram, and this router creates 320 bytes fragment. These are 3 in number, 320, 320, 320, and last fragment is of 100 bytes only with a 20 byte header. Okay, so total 4 fragments are created. It has fragmented because the MTU of this link or this network is 320 bytes. Okay, so maximum size of IP packet here is 320 only. Now, suppose one of these fragments, fragment number 3, is received by this router. This router sees that MTU of outgoing link or MTU of this network is 5000 bytes and the fragment is only of 320 bytes. Will this router just reassemble all of them? This is the question. Answer is no. Router will just forward the fragment as it was received. Okay. It will never reassemble because possibility is that this router may not get all of the fragments. Okay. Suppose this last fragment takes this path. Okay. So this router will keep on waiting infinitely and it will never get this last fragment. Okay. Second reason is there is a possibility that if you recombine all of the fragments here and create this original datagram once again, so there is a possibility that in the path fragmentation might be required again. Okay, so you don't want to do extra work. Okay, see, already fragmentation has been done here and you have smaller fragments, so just send them as it is because smaller fragments will have a higher chance of passing through the entire network. See, here the limitation was 320. Maybe here also there is a limitation of 320 bytes. So if you reassemble and create 1020 byte datagram here only, then again fragmentation might be required somewhere in the path. Okay. So simply don't recombine all of the fragments. Just let them pass as it is. And it should be recombined. The fragments must be recombined at destination only. So statement number 3 is false. Answer to this question is only statement number 2 is correct. Okay.